All right, ladies and gentlemen, we're starting back on section 8.6. We just got done talking about graphing quadratics. And again, just as a quick overview, we started off with just knowing that quadratics are horseshoe shaped, right? They have peaks and valleys. The peaks and valleys they're known as vertexes or vertices if you have multiple of them. Quadratics only have one, so there's the only reason why we call it a vertex, not vertice, which is a point. Okay, so an example of this, well, I'm going to go back one to one lecture note. So it's these points right here or right there. Okay. We also learned that you have these axes of symmetry that are happening. Okay, so if we know what the vertex is, then we can figure out what the axis of symmetry is, right? So the whole point was to know what happens. Okay, well, how do these vertexes come about, and then how are the graphs looked? Well, that led us into the next lecture. Well, the next lecture talked about transformations. Well, that if we have it in a certain form, which is vertex form, right, we can identify the vertex, which is the opposite of this and this, right? So it'll be the opposite of the number that's on the inside. And why? Because of the opposite moving piece, right? And then the axis of symmetry go through it. And don't forget that if you have a negative coefficient outside of that x squared, that thing would flip it upside down. Okay, so what this means is that, and let's do a couple quick ones just to warm up and make sure we're okay here. Okay, because I know we got through one example and I figured it was self-explanatory, but let's make sure we're good. So let's say I had 2x minus 1 squared plus 3. Then we know the vertex, without even going through drawing 12 graphs, and now I don't have to draw 12 graphs anymore because I already know what the vertex is. The vertex will be the opposite of this number. Since that's a -1, it will be a +1. And then whatever this number needs to be. Okay, so I start just by drawing that. So here's my graph. I don't have to go through drawing those 4 graphs anymore. Isn't that beautiful? Now we have 1 and 1, 2, 3. Boom, that is my vertex. Okay, now the question now is it opening upward or downward? Well, this number is positive, so it's for sure opening upward. So, bloop, bloop, done. Okay, so before I showed you guys how each piece played to make it move around, right? But now you should get to the point where it should only take you one graph, drop down your vertex, is it opening upward or downward, you're done, okay? Not quite, because we still need to talk about, which we're going to talk about today, which is how we find those things called X and Y intercepts, okay? So, X and Y intercepts are really not all that bad, and you've seen them before, okay? So let's start with a problem that may make our lives a little easier, okay? And I'm going to go into the new lecture notes for this time, which is X and Y intercepts, okay? So there are two types, X and Y intercepts, and why are they called intercepts? So I don't care. I'm just going to draw a squiggly looking, oh my goodness, my graphs are awful. Oh my God, that's not any better. That's insane. Drawing a straight line is not easy. I don't care what kind. I'm about to draw the weirdest squiggly you've ever seen. Oh, that's not that weird. Okay. I don't care what a graph looks like. There's always going to be places where it crosses the two axes, which is the x-axis, okay, and the y-axis. And the y-axis, I'll make that thing red. Okay, and why am I starting with this? Because if we're going to find these things for quadratics, we've got to at least know what they are, okay? Well, these are points, right? But they're special points. And why are they special? Well, if you remember, and I don't know if you guys recall us talking about this, but for that point, I know one of those two, the x or the y value. I'm going to ask you guys, which one of these two do I know, x or y? Stop and think about it. Clearly, I don't know the y because I don't know how tall it is, okay? It's crossing the y-axis somewhere. I don't know where that is, so I don't know the y. What I do know is the x, because the x has to be at 0, okay? So the way I remember it is that my y-intercept, I'm searching for the y, okay? I'm searching for it. Since I don't know where they are, that's the question mark in my life. And likewise, here, the y's are 0 because you're sitting on top of the x-axis, but you don't know what they are. Okay, so you could have multiple. Just be very, very careful. So bottom line is all you need to know. So if you have a function, so for a function, any function, or non-function for that matter, even some, when you get into Calc 3 and you start having ellipses and circles and all those good things, then you can really and you start to use them in a bigger kind of way, then you can use other things in functions, but it's the same concept fundamentally. At that point, it'll be all the same to you guys. So for a function, f of x, say, equals x squared plus 3x plus 2. Okay, basic guy. All right. To find, actually, you know, for any function, you don't even need, it has to be that. It could be any function. Okay, so any function. Okay, the x-intercept, in order to find it, I must make the y 0 and then solve for the x, and then likewise for the y-intercept, we're going to make the x 0 and then solve for the y. Okay, very, very simple. Easy peasy. Okay, we can do this with any graph. As you're going to see, in 1800s, we're going to do this, it seems like, in every chapter. So it's something to get used to doing now. Okay, so let's do an example real quick. Example, we've been building up from nothing, so here we go. We're going to sketch the graph. And what I want to do is sketch the graph, but I want to do it labeling all the information. Labeling the vertex, axis of symmetry, which I'm going to abbreviate as AOS because I don't feel like going through all that. Axis of symmetry and intercepts. And yes, when they say intercepts, they are meaning X and Y, but you have to go through and you have to find all those. So I'm just going to find them all at once, all right? So I don't know how you guys like to do stuff, but I don't like to work without all the information. Like, I don't like making any decisions in life without all of the information. So what I'm going to do is I'm going to list all that information out, and then hopefully I can see what's going on. Now, I haven't written the function down yet, so here it is. F of x equals -2 x plus 1 squared. Let me make sure I make this workable because it might not work. Plus 8. Okay? So what we're going to do is we're going to look for the x and y intercepts, and we're going to find all that information. We're going to graph it. Now, you're probably saying to yourself, well, Resh, you keep saying quadratics. I've never seen a quadratic look like this. Okay, well, you don't get ahead of yourself, okay? Be patient. But if I were to multiply this out, and you can check me on this, I think I end up getting -2x squared minus 4x plus 6 when it's all said and done. So every quadratic is going to look like this, but this has a different name. This is called standard form. This is just a sidebar. And this is called vertex form. And we always like it in vertex form because if we know vertex form, then we get all this information that is cool, like the vertex, the axis of symmetry, and then we can find the x and y intercepts very easily. All right, so check it out. So let's get all the info here. Now that we know what's going on, let me check my time. My time's okay. I know that this number is a +1 and this number is a +8, and I'm just going to highlight the big details so we don't forget what they do or where they come from. Are they important? And I'm going to make this negative a green. All right, so this means that I should be able to draw the graph now, okay? And I'm going to try to draw it to the best of my ability. Actually, no, remember, find all your info. So here we go. Vertex. Well, we already know about this. This is the opposite of that +1, which is going to give us a -1. And whatever the heck that other number is, because it's going to shift up 8, and that is going to be what it is. So that's going to be an 8, okay? It is going to flip upside down. Why? Because of the negative that's in the front. So don't forget to flip it upside down. So flip up, down. I'll just write it over on top of it, but it's not something I really write down on paper because it's some, I guess we should write it down. Flip up, down. But I think that's something you can remember. You don't have to write that down, okay? And likewise, now that I got the vertex, now I get the axis of symmetry for free. So the axis of symmetry, the place I would slice it is going to be the vertical line. X equals, well, what's the number? Well, -1. Easy peasy because it goes through the vertex. All right? So now we got that. Well, axis of symmetry, well, the last thing we need to do is find our intercepts, okay? We're going to start with the y-intercept. Okay, so the y-intercept, again, what does that mean we're looking for? We're looking for the y. What is happening here? My bad, guys. I have big hands. We're looking for the y. Okay? But we are currently, but the x's are 0. So what does that mean? Well, if we have a function that looks like f of x equals -2x Negative 2, x plus 1 squared plus 8. Well, if I'm making my x's 0, that means plug in 0 everywhere, right? So that's fundamentally what I'm going to do. I'm going to plug in 0. Literally, you're going to see me plug in, if I can do this without erasing more, 0 for everything. All right, now let's grind through it and see what we get. I'm going to fly negative 2 plus 8. I get 6. So I get the piece of information I need is that this is going to be 0, 6. Easy. All right, X-Intercepts. All right, this is where you get to use all those fun things you learned in Chapter 7. All right, well, this one is easy. I'm searching for the x's. Y is 0. Well, y is the same as f of x, right? So I'm going to make f of x equal to 0. And now let's grind through this. Okay, so no need to multiply this out, people, because if you're already in vertex form, notice that your x is already in one spot, completely isolated for. So I can actually go ahead and solve for that because x is already in one spot. So that's what this is kind of cool for. Standard form, you'd have to use, because this is the same part, remember? This is the same as that. We did it earlier. This would require you to factor, but it being into vertex form gives us great superiority even in terms of solving because it's already in one spot. Watch, I'll show you. Okay, so anytime we were trying to get to solve for x, we need to isolate for it, which means I'm going to subtract 8 off onto the other side. All right, and now I'm going to divide by negative 2, which will give me a positive 4 on that side after I do it. But note, I still have this. Okay, people. Chapter 7, you guys learned about undoing squares. If you undo a square, you must square root, right? So if we square root, don't forget that when you square root, that number will now be plus or minus. That is a big deal. Do not forget that. So now we end up with something very, very, very cute, which is x plus 1 equals plus or minus 2. This is why that plus or minus is a valuable thing, because if you didn't do this, and you'd have to multiply it all out, try to factor it apart, and then set each piece equal to 0, which is much harder because you have to go through the process of putting it and multiplying it out. This makes it way easier, okay? So now, this is just 2 problems, and most of you guys might not even need to write this. So I'm going to see when x plus 1 equals 2 and x plus 1 equals negative 2. So x equals 1, x equals minus 3. So this means, not that my point is 1, negative 3. That's not what this means. That means when my y is 0, I have x at 1. It crosses at 1, and it also crosses at 3 when y is 0. So this means not only do I have a vertex, the axis of symmetry, the y-intercepts, I have 2 x-intercepts. But let's be real. Why does that make sense? Well, let's take a look-see here. Okay? And I'm just going to plot our points here. I want to plot stuff to make it look clean. So here's negative 1, here's 8. 1, 2, 3, 4, 5, 6, 7, 8. And you told me this is opening downward. The axis of symmetry goes down through here. I'm not going to draw it yet, though, because I do not want... I don't know how skinny or big to make the graph, and I want it to look nice. Okay, so I'm going to plot the other pieces. 0, 6, 1, 2, 3, 4, 5, 6 is my y. And then the x is 1, 0. And then I got 1 at negative 1, negative 2, negative 3, 0. So you can kind of see that it kind of meets up with everything we talked about. Okay, and you want to label all your stuff. Okay, I always like to label it on the graph, but you already have it on the side there. You've already got it covered, but it works out. 0, 6, and then let's see here. What was this again? This is negative 1, 8. Okay, so easy peasy, not that big of a deal. Okay, let's do one more. Make sure we're okay. It should be really, really quick. Okay, now sometimes you might have something that is not as clean as you'd like to be. So same thing, graph, okay? Sketch the graph, labeling, vertex, axis of symmetry, and intercepts, if applicable, okay? So now here's your graph. F of x equals x plus 1 squared plus 1, okay? So, it's positive, which means it's already opening upward. The vertex, again, we're going to get that information immediately, is the opposite of this number, which is minus 1. And we'll make it 2, so you guys actually know which it is, okay? 2, Okay? Okay, we'll make this one. And there's a reason why, guys. I want the problem to work out a certain way, and I didn't really plan on this one, but I think it's a good problem. All right, it's -1, so that means now the vertex would be the opposite of 2 and whatever this number is, which is 1. All right, we're all on the same page, okay? That means the axis of symmetry is x equals -2. Easy. Is it opening upward or downward? Well, it's positive here because there's no negative. Therefore, it has to be opening upward. Okay, so let's get our, here goes my big hands again. Let's look at the y-intercept now. Well, we're going to make x equal to 0. Okay, now you guys probably are good enough by now to do this in your head, and if you are, that's where you should be, okay? I did this in my head, I got 5, and again, you're just plugging in 0 for x into your function. So you get 0 plus 2 squared plus 1, which gives me 5. And then the x-intercepts, now we got to do some solving, but that's okay. But watch what happens here. This is the main point of this problem. So again, x-intercepts, y is 0, looking for x's. So I'm going to make my y, which is f of x, equal to 0. Okay? Watch what happens here. I subtract 1 off, like we did last time, right? X is already isolated for it. No need to multiply it out. Okay? And then to undo a square, we already know to square root it. But look what happens here. Oh, look, a square root of -1, and don't forget plus or minus is there. So what do we end up with? We end up with plus or minus I. And you're like, well, heck, how in the world am I going to have some x-intercepts that are at 2 plus I, 0, and 2 minus I, 0? Because the moral of the story is we're not in the real system right now. This means that they are floating in space. So watch what this means. So our graph, just off the first pieces of detail, and I want you to use some common sense here. I always believe common sense is the best sense to have. So watch this. You're saying the vertex is at -2, 1. Axis of symmetry is going through it, obviously. But it's positive, which means it opens upward. That means this point has to be 0, 5, right? But if that's the case, there shouldn't be any x-intercepts. Hence why they're imaginary. So, in this case, these are none. Okay, so please make sure you pay attention to that. You are not always guaranteed to have 2 intercepts like we had in the last problem. Okay, sometimes you might just have 1. Okay, it's no big deal. Could happen. Okay, so, but it's all the same thing. Just get all the information and then graph it all out. Now, here's the good news. The good news is if it's in this form, good news. If it's in the form ax plus k squared plus h, then we are happy because vertex form means we can graph in. We can graph. Bad news. We have to turn the standard form, which is this guy, into that guy. And that is not easy to do, and we're going to save that for the very next video. Okay, guys, thanks for sticking around. I know it was a longer video, but I wanted to make sure we had all the details. And we've been building on the story for the last 2 or 3 times, all right? So, this is signing off, Sanders Helper. And then, again, in order to go someplace you've never been, guys, you're going to have to do some things you've never done. So, get ready for the next video, because all the little details, which was now, were easy. The next one's going to be where it gets tricky. All right, signing off.